Hello. Oh man, I'm Mr. Hyman's illegitimate son. Uh, this is so stupid. I don't even know where I'm going to use this. I'm going to go ahead and take you through an example of this. You'll never use it, but let's do it anyway. We need to go ahead and complete the square on this one because it's not going to work the way it is. So yeah, it stinks. It's so stupid, but you got to go ahead and complete the square on this. So I like to go ahead and, well, nobody likes to, let's face it, but I'm going to go ahead and put the x's beside each other, and I'm going to put the y's beside each other because I got to complete the square form. And I'm just going to take this 4, and I don't even like it, so I'm going to take it to the other side. All right, and then let's go ahead and solve this thing. But you can't do complete the square yet because you've got a 4 with this x squared, and it's got to just be x squared to complete the square. It's so dumb. Oh, I can't stand it. So I'm going to pull the 4 out, and I get x squared minus 2x, and then leave a space so you can complete the square. And I don't have to pull anything out of the y's because it's already a 1 in front. So I'm just writing it down. Get off my back. Goodness. And leave a space again. Oh, you're so stupid. You didn't leave a space. Leave a space. I told you that. So leave a space to complete the square. And then the rule for completing the square is b over 2 squared. I don't know why. Mr. McConnell told me it was. Goodness, that's why it's the rule. So it's half the middle term squared. So half of -2 is -1, and you square it, and you get a +1. And then whatever you do to one side, you got to do the other. But don't put a +1 right here, because it's wrong if you do that. You're just stupid if you do that. Because I didn't really add 1 to this side of the equation. I did 4 times 1 to this side of the equation. So I've got to add 4 over here to account for adding 1 right here. Because 4 times 1 is what I really did to that side of the equation. Just pay attention. It's not that hard. Goodness. All right, so the next part, I'm going to go ahead and do that b over 2 squared again. And half of 4 is 2, and 2 squared is 4. So I'm going to add 4 to this side. And then there's nothing to distribute to this 4. So I just add 4 to that side. This one's so easy. I don't even know why they make us do it. All right, so, and now I'm going to go ahead and factor these. So I got 4, and I'm going to make my 2 sets of parentheses. And it's going to be x and x, and it's going to be a 1 and a 1. And they both got to be negative to make them multiply to +1 and add up to -2. And the next one, I'm just going to factor it as well, and it'll be y plus 2 and y plus 2. And I'll clean up that other side on the next step. Just get off my back. I'll do it. I'll do it, okay? So the other side, 2 of the 4s will cancel, but you still got 4 left. And I want to write this as y plus 2 squared because that's what it said on the front. That's why you do that. And then I'm going to have 4 outside of x minus 1 squared. Who even cares? And then you want to equal to 1. So you go ahead and divide by 4 on everything. And that'll get it equal to 1. These 4s will cancel, and you just get x minus 1 squared over 1. And then plus y plus 2 squared over 4, and then it equals 1. Now you can go ahead and graph it because it's in the form you want, so it's not hard at all. But I don't even want to graph it, so I'm just going to say how to do it. What are you going to do about it? I don't care. So x and y, the center is going to be 1 and -2. Fine, I'll do it. So 1, -2 is my center. And then my a value, remember, it's the bigger one. We heard that guy say it like 20 times on the other side. So a is going to be 2. So this one's going to be stretched vertically. I go 2 units up, 2 units down. That's my vertices there. And then b is 1. So I'm going to go 1 unit left, 1 unit right. There are my co-vertices. And I'm not even going to find the foci for this one because we've done it too many times. So there you go. All right, let's go to the last one. I can't do the spoiled teenager thing anymore. Let's do the last one. All right, so last one, we got example 4. You've got a hall that is 100 feet in length, is designed to be a whisper gallery. So you guys might have experienced this before in the Capitol building when you took your 8th grade trip. All right, there is a whisper gallery. So it's 100 feet in length across. All right, the foci are located 25 feet from the center. So I got my foci here, and my foci here, my center would be here, and the length, I'll put CEN for center, this is 25 feet, and it's 100 feet all the way across, so I'm going to mark it like this, that is 50 feet. All right, and they want to know how high the ceiling will be, so this is what, we got a semi-ellipse going here, all right? And they want to know how high the ceiling would be. So this right here is what they're after, okay, is that length right there, all right? You got to connect this and make it into ellipse terms. My 50 is just the A value. The major axis is across here. The reason I know it's the major axis is because the foci are on it. It has to be the major axis because foci are always on the major axis. So I've got A is 50. And I also know that C is 25. The length from the center to the focus is 25. And they want to know this height right here. Well, that's just B. It's the semi-minor axis length. So I'm going to go ahead and find B. And to do that, I'm going to do the messed up Pythagorean theorem. C squared equals A squared minus B squared. My only unknown is B. So I'm just plugging in what I know. So I'm going to have 25 squared equals 50 squared minus B squared. And then I go ahead and take 25 squared, which is, oh boy, let me do this in my head, 625. And 50 squared is going to be 2,500. And I got minus B squared. This all looks weird because I'm going to subtract 2,500. And everybody panics and says, oh, no, it's negative. Well, it's OK because B squared is also negative. They'll cancel. So I'm going to take 625 minus 2,500. And I'm going to get negative 1,875 there. And that equals negative B squared. Divide by -1, get rid of the negatives. And then go ahead and square root this thing. All right, so the square root of, oh boy, I don't know if I can do this one in my head. All right, I'm going to get out my phone here. 1875, square root of it comes out to 43.3. All right, so B is 0.3. That's how high that ceiling would need to be. All right, the last thing on here is eccentricity. All eccentricity is how stretched out it is. The closer the eccentricity gets to 1, as you can see here, the more stretched out it's going to be. When the eccentricity gets closer to 0, it gets closer to being a circle. Okay, so an eccentricity of 0 is actually a circle. An eccentricity of 1 would be a literal segment, because it would be so stretched out that it would be squished right on top of itself. So this would be an eccentricity of 1, and an eccentricity of 0 would be on the other end of the spectrum, and it would just be a flat-out circle, okay? And this is just a formula to find eccentricity. I'm not even going to ask you about it. I just wanted to throw that term out at you in case you ever hear it in the future. It's not a big deal. All right, take care. You guys go ahead and do the practice tomorrow, okay? Notes were enough for today. We'll do the practice tomorrow, and that'll be all you do tomorrow. All right, take care.